Alright, today we'll be looking at past questions and answer in JAMB, WAEC, IJMB. But before we continue, I want to welcome you to School of Chemistry. If it is your first time, please click on the subscribe button so that you can have access to a whole number of videos, both the past and the new ones that I will be uploading. Alright, the first question we're looking at is the electronic configuration of an element is 1s2, 2s2, 2p6, 3x2, and 3p3. The question now is, how many unpaired electrons are there in the element? Now remember, we're discussing the orbitals, and we say the s orbital can take a maximum of 2 electrons, the p orbital the maximum of 6 electrons, and the d10 and the f orbital a maximum of 14 electrons. Now they are giving us this configuration. It means this one is full, this orbital is completely filled, this is completely filled, this is completely filled, this is all orbital that is not completely filled, because p should take a maximum of what? 6 electrons. Why this one is having 3 electrons. So now, to deal with our p3p orbital, we have to check. And remember the rule is that we have to fill your orbital singly first before pairing will occur. And because we have 3p3, we have our px, the pz, and the py. We'll first of all fill this p orbital singly. We have the first electron, the second electron, and the third electron, and that is the 3p3 orbital sub-level. Now, because there are 3, that is all. Now we'll come. How many unpaired we have? This one is unpaired, this one is unpaired, this one is unpaired. But for understanding, let's see the whole configuration so that you understand. Let's do the whole configuration so you know the number of unpaired electrons. We have 1s2, 1s2. The s sub-level has only 1 orbital, so the s2, 1s2 will be there. We have 2s2, 1 orbital, so the 2 electrons will be here. We have 2p6, 2p6. 3 orbitals are here in the p orbital. 1, 2, 3. So you first of all fill singly. There are 6. Before pairing will occur, they are all paired now. This is a pair. You know, 2 makes a pair. This is 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 a pair. Now, 3x2. The s orbital has only 1. The s sublevel has only 1 orbital. The 2 electrons will be there. Now we have 3p3. Remember, the p orbital has sublevel has only 3 orbitals. So we're going to have 1 electron filled singly first, the second electron, and the third electron. Now the question says, how many unpaired electrons are there in the element? Now the number of unpaired electrons are 1, 2, 3. So the correct option is what? Option C. And that's how to go about answering that question. Alright, second question. An example of a polysaccharide is A, dextrose, B, mannose, C, glucose, D, starch. Remember, polysaccharides are simply long chains of monosaccharides. Long chains of monosaccharides. So from that, you know that this is a disaccharide, this is a disaccharide, this is a monosaccharide. So the only polysaccharide we have here is starch. And we have polysaccharides like starch, glycogen, and cellulose that have glucose as their basic unit. You know, they are formed by glycosidic bonds. So the correct answer here is option D. This is a polysaccharide. Alright, question number 3. 8 grams of CH4 occupies 11.2 dm cube at STP. What volume would 22 grams of CH3CH2CH3 occupy under the same condition? Option A, 3.7 dm cube. Option B, 11.2 dm cube. Option D, 22.4 dm cube. Option D, 33 dm cube. How do you go about this question? How are you going to solve it? Now, number one thing is you have to know that 1 mole of a gas at STP occupies what? 22.4 dm³. 1 mole of a gas at STP occupies 22.4 dm³. So meaning that if 8 grams, okay, let's calculate the molar mass for these two substances first. Molar mass of methane, CH4, will be equals to C plus 4 hydrogen, and this will be equals to 12 plus 4 into 1, and this will be equals to 16 grams per mole. Molar mass of propane, CH3, CH2, CH3 will be equals to 3 carbon plus, how many hydrogen? 3, 2, 5, this 8 plus 8 hydrogen will be equals to 3 into 12 plus 8 into 1. And that will be 36. 3 times this is 36 plus 8. And this will give you 44 grams per mole. Now this implies that if 8 grams of CH4 occupies 11.2 dm³, 16 grams of CH4, which is equivalent to 1 mole of CH4, will occupy 22.4 dm³. Now, the molar mass of propane, 44 grams of propane will occupy at STP, 44 grams of propane equals to 1 mole of propane. It will occupy 22.4 dm³. Now the question is, what volume would 22 grams of propane occupy? 22 grams of propane will occupy 22 grams will occupy 22.4 times, you cross multiply 22 divided by what? 44. This here 1, 22 here 1, 22 here 2, 2 here 1, 2 here, you have 11.2. So it will occupy 11.2 dm³. 11.2 dm³. So the correct answer is option B. Alright, question 4. The graph above represents A. Boyle's law, B. Charles' law, C. Graham's law, D. General law. Please, if you're on Facebook, follow the page and like us, comment, leave your question in the comment section. If you're on YouTube, subscribe to the channel, share this to as many as possible, and then make sure you leave your question under the comment section. Now, how do you get about this question? Now, you must know what Boyle's law is, you must know what Charles' law, you must know what Graham's law is for you to be able to answer this question. Now, Boyle's law talks about pressure being inversely proportional to volume at constant temperature. Charles' law talks about volume being directly proportional to what? Temperature at constant temperature. While Graham's law talks about density and what? Rate of what? Diffusion. The general gas equation merges all of them. So this one is out of the equation. This is out of the equation. Now, from what we have volume and temperature. And as volume is increasing, temperature is also what? Increasing. Volume increases, temperature increases. There is no pressure. So Boyle's law is out of it. So the correct answer is what? Charles' law, because you say volume is directly proportional to what? Temperature. As the volume increases, the temperature increases. This is the representation of Charles' law. You have small volume, you have small temperature. You have big volume, you have big temperature. You have a bigger volume, you have a bigger what? Temperature. So as volume increases, temperature will be increasing. Volume is always directly proportional to what? Temperature. So the correct option is what? Option B. We'll keep pushing. Question 5. What are the possible oxidation number of an element if its atomic number is 17? Now, you must remember that before you can answer this question, you must know the electronic configuration of elements and the concept of valence electron and valency. Now, from there, from the electronic configuration, from what they have given us here, they have given us the oxidation number and the number of valence electrons. This is what is being expressed on the board. Now, write the electronic configuration of this element. We're going to have 2, 8, 7. That is the electronic configuration of the element. If it's this one, you understand, you have share 1 will take 2 electrons. The second share will take 8. And the third share will take 7. 1, 2, 3, 4, 5, 6, 7. Or if it's the SPDF, you have 1s2, 2s2, 2p6, 3s2, 3p5. So all of them, this is the valence electron. This is the valence electron 7. Valence electron here, the electron in the atom share 1, 2, 3, 4, 5, 6, 7. Valence electron here, this is the atom share 3. You have 2 plus 5 is 7. Now the question is, what is the oxidation number of the element? Now, first of all, you know that the element has 7 electrons in the atom share. So option D has 6 is wrong. Option C has 5 is wrong. Option B has 6 is wrong. This one has 7. But let's check for the oxidation number. What is the oxidation number? Is the number that the combining power of an element. So this element having 7 electrons in the atom share, it has 2 options. Either to give out the electron in the atom share and attain this octet structure, or accept 1 electron and what? Attain the octet structure. Now, because there are 7 electrons, it will be easier to accept 1 electron and become stable than to give out the 7. And when you accept an electron, the sign is what? A minus, showing that you are actually what? Gaining an electron. You are borrowing because it's not here, so it should be negative. So the correct option is option A. Alright, number 6. The IUPAC name of CH3, CH2, COOCH2, CH3 is? Alright, now this is an ester, an alkaloid. You know, their formation is by what? The reaction between alkaloic acids and what? Alkanols. Now, from this, water molecule is lost to form this. So, in forming this, the hydroxy system will lose the H group, while the alkanoic acid will lose an OH. So, they will form this. So, in naming this compound, you normally split it into 2. The part coming from the alkanoid, you name it first, while the part coming from the alkanoic acid will join. So, from this side, okay, just split the compound before or split it into 2 imaginarily. So from this side we have an ethyl. Now count the number of carbons. 1, 2, 3. There are 3 carbons here, so it's going to be the propane series. But because the propane has a double O, it's going to be an OH. Propanoid. So the correct option, the name is what? Ethyl propanoid. So the correct option is option what? Option C, ethyl propanoid. A certain hydrocarbon on complete combustion at STP produce 89.6 dm³ of CO2 and 54 grams of water. The hydrocarbon should be A, C6, H6, B, C4, H10, C, C5, H10, D, C4, H6. First of all, you must remember the formula for the combustion of alkane, which says CXHY plus X plus Y over X plus Y over 4 O2 will form XCO2 plus y over 2 H2O. Now from the given equation, 89.6 dmq of CO2 produce X mole. Okay, a certain hydrocarbon on complete combustion at STP produce 89.6 of this. So it means that 89.6 dmq produce X mole of what? CO2. That means 22.4 dmq will produce 1 mole of what? CO2. Because at STP, every gas, 1 mole of every gas occupies 22.4 dmq. If you cross multiply, you have X times 22.4 will be equals to 1 times 89.6. So that X moles will be equals to 89.6 divided by 22.4. Press your calculator, what do we get? If you press your calculator, you are going to get 4 moles of CO2. So our X is equals to 4 moles. Now we are going to look for what? Y. A certain hydrocarbon on complete combustion at STP produced 89.6 dmq of CO2 and 54 grams of water. So 54 grams of H2O will produce Y over 2 moles of Y over 2 moles of H2O. Now, if you calculate the molar mass of water, you have molar mass of water, you are going to have hydrogen, 2 hydrogen plus oxygen, and it will give you 16 grams per mole. So it means that 16 grams, or the molar mass of anything, is equivalent to 1 mole of that thing. It implies that 16 grams of water will produce 1 mole of water. So if you cross multiply this, you are going to get Y over 2 will be equals to what? 54 multiplied by 1 divided by what? 16. Press your calculator, what do you get? 54 divided by, did I say 16? 18 rather. The molar mass of water is 18. Divided by 18. If you press your calculator, what do you get? You are going to get 3 moles of water. But remember, Y over 2 is now equals to what? 3. So that Y will be equals to 3 times 2, and is equals to 6 moles. That means Y is equals to 6, X is equals to 4. So the formula of the compound, because it is CX, H that is the hydrocarbon, is going to be C4H6. And that brings the correct option to option what? D. So that is the answer. Question 9. 2-methyl-but-1-ene is an isomer of A. 3-methyl-pent-1-ene, B. 3-methyl-pent-2-ene, C. but-2-ene, D. pen-2-ene. Now, for you to be able to answer this question, you must know what is an isomer. An isomer, simply put, isomers are compounds having the same molecular formula but different structural formulas. The same, different. So now, the molecular formula tells us the number of compound of elements present in a number of each element present in a given compound, while the structural formula tells us the arrangement of this element. From each of these names given, we'll be able to tell the arrangement of the element, and from that arrangement, we'll be able to condense them to have our molecular formula. And it is the one that has the same molecular formula as this that will give us the correct answer. So first of all, we have to know the molecular formula of this compound. 2-methyl but 1 in, 1, 2, 3, 4. This is my but with the double bond on carbon 1. That is why it's on 1 in, and my methyl is on carbon 2. So I have to fill the rest with what? Hydrogen. 1, 2. It needs 2 hydrogen. 1, 2, 3, 4 is filled. 1, 2. It needs 2 hydrogen. 1. It needs 3 hydrogen. So I'll write the molecular formula. 1, 2, 3, 4. C4. Now let's number of hydrogen. 3, 4, 5, 8, 10. H10. This is the, I'm not correct. 1, 2, 3, 4, 5. Yeah. C5, H10. That is the molecular formula. Now let's check. First of all, anyone that does not have 5 carbon, we will leave it. It means it does not have the same formula. 3-methyl pent 1 in. 1, 2, 3, 4, 5. These are pent 1. It has a methyl. CH3 will be here. Let's count the carbon. 1, 2, 3, 4, 5, 6. It's not there. But okay, let's finish it. We fill it with 2. Here. 1, 2, 1, 2, 1. Okay, there are 3 here. So let's count the hydrogen. 3, 4, 5, 6, 7, 10, 12. So we're going to have 6, 6, H12. So this is not correct because it does not have the same formula as this. Let's go to the second one. 3-methyl pent 2 in. It's going to be 1, 2, 3. Pent 2. 1, 2, 3, 4, 5. 3-methyl CH3. So we'll feed the rest. H3, 1, 1, 1, 2, 3, 4. This is feed. This one needs 1, 1, 2, 3, 4. This one needs 3. Let's count. 3, 4, plus 3, 7, 8, 9, plus 3, 12. Is still C, 1, 2, 3, 4, 5, 6, 6, 6, H12. This and this are the same. So it's wrong. Put 2 in. Put 2 in. We're going to have put 2 in. 1, 2, 3, 4. Put 2 in. The double bond is here. So we're going to fill H3. 1, 1, 2, 3, 4. 1, 2, 3, 4. Here is 3. So let's count. 3, 4, 5 plus. Am I correct? 1, 2, 3. 1, 2, 3, 4. Okay, it's balanced. 1, 2, 3, 4 is balanced. 1, 2, 3, 4 is balanced. 3, 4, 5, 8. 1, 2, 3, 4. So the carbon are 4 and the hydrogen are 8. So this one is not correct. Pent 2 in. Pent 2 in. We're going to have 1, 2, 3, 4, 5. The double bond is on carbon number 2. So that is the pent 2 now. So we'll fill the rest with hydrogen. 3. 1, 2, 3. It needs 1 more bond. 1, 1, 2, 3. It needs 1 more bond. 1. 1 needs 2. And here needs 3. Let's calculate. 3, 4, 5, 6, 7. Plus 3. 10. 1, 2, 3, 4, 5. So we have C5, 5 carbon atom, and 10 hydrogen. I think that is the same thing as this. So the correct answer is option D. So that is how to go about knowing your isomers. The IUPAC name of the compound CF3 CHBr Cl is A. 2-chloro 2-bromo 1,1,1-trifluoroethane. B. 2-bromo 2-chloro 1,1,1-trifluoroethane. C. 1-bromo 1-chloro 2,2,2-trifluoroethane. D. 1,1,1-trifluoro 2-bromo 2-chloroethane. For you to be able to answer this question, what you do? You first of all have to write down the structure of that compound. So we're going to have C, it has F3. So we're going to put 3 fluorine here. That's what it means, CF3. Bonded to another C. This C, we have a hydrogen there. We have a bromine group. And then we have a chlorine. Now you must remember your IUPAC rule. You choose the parent alkane. The parent alkane now is the longest chain. That is the carbon, the 2 carbon atoms. So that means it's going to be an ethane series. So we must name it after ethane because it is saturated. It has no double bond, no triple bond, and no functional group present. There is functional group. Now, all the substituents are halogens. Chlorine is a halogen. Bromine is a halogen. Fluorine is a halogen. So, where are you going to start numbering from? Because there is a number from the side that give either the functional group or the side chain the smallest possible number. So, which side are you going to start naming this compound from? You are going to number from the side that give the atom with the highest electronegativity dominance, the functional group denomination. Now, between fluorine, chlorine, and bromine in group 7, all of them are electronegative elements. But the most electronegative of them is what? Fluorine, followed by what? Chlorine, then followed by bromine. This is the most electronegative in the group, followed by this, and then this down the group. Electronegative in group 7 decreases down the group. So the most electronegative, as a matter of fact, the most electronegative element in the periodic table is fluorine. And because it is the most electronegative, and the effect is electronegativity, fluorine will exhibit the dominance of electronegativity and will be acting as a functional group. And so, we'll number from the side that give the atom that has the dominance the smallest possible number. So this is going to be 1, and this is going to be 2. Now, having done that, we're going to name the other substituents alphabetically. We have bromine, we have chlorine, we have fluorine. So we know that B comes before C, and C comes before F. That means we'll start our naming with what? Bromine. And since bromine is of carbon 2, we're going to start with it and we'll say 2 bromo. Followed by chlorine because C comes before F. 2 chloro. Then we'll have a fluorine on carbon 1. There are 3. So we're going to say the first one is on carbon 1. Second one is on carbon 1. Third one is on carbon 1. So we'll have 1. Because there are 3, we are going to say trifluoro. And because our parent chain is ethane, we'll have what? Ethane. So the name is 2 bromo, 2 chloro, 1 trifluoroethane. And that gives us option what? I think that is option B. So B is the correct answer. Alright, 11. Element X and Y have the electronic configuration 1s2. Let's write it out. 1s2, 2s2, 2p4. This is element X. The element Y, we have 1x2, 2s2, 2p6, 3s2, 3p1. This is element Y. They say respectively, when they combine, the formula of the compound formed is, now before you be able to answer this question, you might be able to deduce the valency of this element. You must know the valence share and know whether the element can accept or what? Give out electron. Now, in this in element X, the valence share is the share with the highest number, and that is 2. On that share, we have 2 electrons and 4 electrons. Combine them together, X has 6 electrons in the atom motion. So X is going to be like this. First share, 1, 2, 1, 2, 1, 2. This is element X. Now element Y has, in the first share, it has 2 electrons. Second share, it has 8. Third share, it has 3. 1, 2, 3. Now, as you can see, this one having 6 electrons. To attain octet structure or the duplex structure, it has to do either of 2 things. Either it give out the whole 6 and become what? Attain the duplex structure, or it accept 2 and attain what? The octet structure. So you see that this element then will prefer to accept 2 electrons and become 2 minor, and that will become the valence of that element, S raised to power 2. 2 minus. Now, why having 3 electrons in that thermal shell, we either accept 5 to attain the octet structure, which is a stable structure, or give out 3 to attain still the octet structure, which is a stable structure. So it will be easier to give out the 3. And when you give out 3, you become positive. So this will become what? Y3 plus. So when 2 of them combine now, you have X2 minus combining with Y3 plus. The rule of valency is they will exchange their valencies. And when they exchange this valency, now you're going to have X3, you write the 3 as a subscript this time, and what? Y2. This will be the formula of the compound. Let's check. We have option A, XY, option B, X2Y, option 3, Y2, X3, normally how it is written, Y2, X3, option D, X2, Y3. So the correct answer is what? Option C. Question 11. By what amount must the temperature of 12 cm³ of nitrogen at 27 degrees Celsius be increased to double the pressure if the final volume is 150 cm³? Assume ideality. Option A, 150 cm³. Option B, 177. Option A, 150 degrees Celsius. Option B, 177 degrees Celsius. Option C, 75 degrees Celsius. And option D, we have what? 120 degrees Celsius. So they say the question is, by what amount must the temperature be increased? By what amount must the temperature be increased? So now, we are going to take the details. How do we solve this? We say V1 is equals to 200 cm³. These are V1. T1 is equals to 27 degrees Celsius. We'll convert that to Kelvin by adding what? 273. And that will give us 300 Kelvin temperature. P1 is equals to P1. Now, they say the increase to double the pressure. That means P2 is equals to 2P1 because I'm going to double the pressure. Now, V2 is equals to 150 cm³. We are looking for T2. T2 is what we are looking for. So from the data we have, use the general gas equation where P1 V1 over T1 is equals to P2 V2 all over T2. We are looking for, we'll make T2 the subject of formula. So we're going to have T2 is equals to P2 V2 T1 all over P1 V1. So our P2 is equal, we'll substitute now. Our P2 will be equals to 2P1 multiplied by our V2, 150 multiplied by our T1, 300. You divide all of that by what? Your P1, which is P1, multiplied by V1, which is 200. So this 0 will cancel this 0. This 2 will cancel this 2. This P will cancel this P. So that our T2 will be equal to what? 450 Kelvin. 450 Kelvin. That is our V2. Let's check what does the option say. What does the question say? By what amount the temperature at 217 will be raised? So if you check by that, by what amount will it be raised? So you are going to subtract from 450. You are going to subtract. Pause.
Not doing that mistake. Go on.
Now from 450, we subtract 273 Kelvin to get a temperature in Celsius, and that will be 177 degrees Celsius. So this is our T2. But the question is not T2. It's by what amount? They say by what amount was the temperature of 270 degrees cm cube of nitrogen at 27 be increased? So from 27, by what amount must the temperature be increased? So the amount is going to be what? 177 minus 27. We are going to get 150 degrees Celsius. So the temperature will be increased by what? 150 degrees Celsius. So the correct answer is option. The combustion of carbon 2 oxide in oxygen can be represented by the equation 2CO plus O2 to give 2CO2. Calculate the volume of the resulting mixture at the end of the reaction if 50 cm cube of carbon 2 oxide was exploded in 100 cm cube of oxygen. Option A, 75 cm cube. Option B, 125 cm cube. Option C, 100 cm cube. Option D, 50 cm cube. How do you think about this question? First of all, let's write down the equation. 2CO plus O2 to form (2CO plus O2 form 2CO2. Now, let's look at the mole ratio. Mole ratio. This is going to be 2:1:2. Let's look at the volume ratio. It means 2 cm cube of this, we need 1 cm cube of this to form 2 cm cube of CO2. Let's look at the volume of gases. Here, 50 cm cube of CO is available, 100 cm cube of oxygen is available. Here, nothing is formed yet, 0 cm cube. Now, reacting volume. Reacting volume. What volume is reacting? Remember, anytime 2 cm cube of this is reacting, 1 cm cube of this will react. So, if 50 cm cube of, okay, let me take it gradually. If 2 cm cube of this react, 1 of this will react. If 10 of this react, 5 of this will react. If 20 of this react, how many of this will react? 20 of this react, 10 of this react. So if 50 of this react, 25, not 5, 25 cm cube of this will need to react. 25 cm cube will react. And 25 cm cube react. Anytime 2 of this react, 2 of this is formed. So when 50 of this react, 50 of that, 50 cm cube will be formed. Now, resulting volume after reaction, here, or volume left. Volume left after reaction. 0 cm cube will be left because all of this is used. 100 minus 25, 75 cm cube will be left. This one is formed, so it will still be in the system, 50 cm cube. So they say we should calculate what? They calculate the volume of the resulting mixture. So volume of resulting mixture will be equal to 75 because this will be in the system mixed with 50, and this will be equal to 125 cm cube. So the correct answer is option B, 125 cm cube. The general formula of alkanones is, so if you don't call them alkanones, you call them ketones. This one is from the homologous series and functional group. If you don't know the functional group for the alkanones, you don't know the answer. So here we have RCHO. This is the formula for what? Alkanes. RCOH. RCOR. This is for what? This is for alkanones. RCOOH. This is for alkanoic acids. RCOOR. This is for alkanoids, for esters. So if you don't know the functional group, you fail this question. The correct answer is what? B, RCOR. That's the correct answer for this question. Temporary hard water is formed when rainwater containing dissolved carbon dioxide flows over deposits of A. CaCO3, B. Na2CO3, C. Na2SO4, D. CaSO4. Now, note this. Permanent hardness is caused by the presence of magnesium. Hardness of water is caused by the presence of magnesium ion and calcium ion. Now, where permanent hardness is caused by the presence of what? A sulfate. Temporary hardness is caused by the presence of what? Bicarbonates or bicarbonates. CO3 2 minus. So, in the case of permanent hardness, it is caused by the presence of magnesium or calcium sulfate, while temporary hardness is caused by the presence of magnesium or calcium carbonate, either combined or isolated. So, in this question, when temporary water is formed, when rainwater containing dissolved carbon dioxide flows over the deposit of what? Calcium carbonate. This is what will form what? Temporary hardness. Option A. Alright, question 16. We are making progress. I hope you're following the class. If it's your first time on this channel, please make sure you subscribe. If you're following us on on Facebook, make sure you follow us. Like our page, share. Anyway you are, make sure you share this. And if you have a question, please leave it in the comment section. If you have a contribution, please also leave it in the comment section. Question 16. The acid anhydride that will produce weak acid in water is A. SO3, B. NO2, C. SO2, D. CO2. Now, SO3, NO2, and SO2 will all produce weak acid. Tetrasulfate 6 acid is a very strong acid. Tetraoxosulfate 6 acid, H2SO4, which will come from both SO3 and SO4, SO2, is a very strong acid. And nitric acid or trioxonitrate 5 acid is also a very strong acid. So the reaction of CO2 with water to form carbonic acid, which is a very weak acid, is actually the only weak acid that will form here. So the option is option D. That's the correct answer. 17. The constituents of air necessary in the roasting process are A. Oxygen and water, B. Argon and carbon dioxide, C. CO2 and water, D. Oxygen and CO2. So basically, in the roasting process, the constituent needed is what? Oxygen and what? Water. That is all that is needed to cause roasting. So the correct option here is option A. Let's move. A given mass of gas occupies 2 dm³ at 300 Kelvin. So to solve this, you say V1 is equals to 2 dm³, T1 is equals to 300 Kelvin. At what temperature will each volume be double? So V2 is going to be what? 2 times 2 dm³ because the volume will be double. And T2 is what we are looking for, keeping the pressure constant. Boyle's law says that V is directly proportional to T at constant pressure. That means V1 over T1 is equals to V2 over T2. So that T2 now will be equals to V2 T1 all over V1. And this will be equals to our V2 is 2 times 2, that is 4. Well, this is 2 times 2, that is 4 dm³, multiplied by T1, 300, multiplied by V1, which is 2. 2 here, 1, 2 here, 2. 2 times 300. T2 now will be equals to 600 Kelvin. And that will be the correct answer. So our correct option is option D, 600 Kelvin. Alright, number 19. The oxidation number of iodine in KiO3 is A plus 7, B plus 3, C plus 5, D plus 6. Remember we discussed oxidation number, how to calculate oxidation number of element. And there's a rule we say the sum of all the oxidation number of elements in a compound is equals to what? 0. So the oxidation number of K plus I plus 3 oxygen will be equals to 0. We know that K has an oxidation state of +1 because it's in group 1. We are looking for the oxidation state of I, is variable here, plus 3. Oxidation state of oxygen is -2, equals to 0. So, we're going to have plus, okay, I, let's bring our I here, I plus 1 minus 3 times -2 become -6 will be equals to 0. So that I minus 5 will be equals to plus 1 minus 6 will be -5 will be equals to 0. So I will be equals to what? 5. So the correct option is option C. Next question. An isomer of C5H12 is. Now remember, isomers have the same molecular formula but different structural formula. So let's see which of these will have the same molecular formula as this. 2-ethylbutane A, 2-ethylbutane. They call it butane, that means it has 4 carbon. The ethyl, 2-ethylbutane, C2H5 is here. So we feel the remaining hydrogen is a butane, so it should be saturated with what? Hydrogen. H3. So let's calculate the number of carbon. 1, 2, 3, 4, 5, 6. So we have 6, 6, H. How many hydrogen? 3, 4, 5, 8, 9, plus 5, 14. H14. So 14 is not the same as what? C5H12. Next, let's look at B. Butane. Butane is a 1, 2, 3, 4. H3, 1, 1, 1, 1, 1, 2, 3. So we're going to have 3, 4, 5, 6, 7, 8, 9, 10. This one is C4H10. The formula is not the same. Isomers must have the same molecular formula, different structural formula. C. 2-methyl-butane. 1, 2, 3, 4. This is butane. The methyl is on carbon number 2. So we have CH3. We can saturate the carbon atoms. 3, 1, 1, 2. Anywhere carbon must have 4 bonds. Not C3, CH3. Alright, let's count. 1, 2, 3, 4, 5. This is C5. Let's count the hydrogen atoms. 3, 4, 5, 8, 9, plus 3, 12. H12. So these and these are the same. So this must be the, but let's calculate the last one. D. 2-methylpropane. 2-methylpropane. So we're going to have propane is 1, 2, 3. 3 carbon. The methyl is on carbon 3. So we'll saturate the remaining ones with hydrogen. So let's calculate carbon atom 1, 2, 3. This is going to be C3. Hydrogen atom 3 plus 3 plus 3, 9 plus 1, 10. H10. It's not the same with what? This. So the correct answer is C5H12, and that is option C. 2-methylbutane is the isomer of C5H5 in the question. Please ask your question in the comment section. Do not forget to subscribe to this channel. If you are following us on YouTube, subscribe. If you are following us on Facebook, do not forget to follow us. Your question in the comment section and your contribution also in the comment section. I'll be attending to each and every one of you. If you're in the WhatsApp section, our classes still continues. Thank you very much for following this section. More questions will come tomorrow. Stay tuned. Thank you.